Today I want to test a little 10 gigahertz 2-watt power amplifier I just built up, and basically this amplifier is using this part, the TGA2535SM, and it's a gallium arsenide part. This is fairly inexpensive, runs about $70. It's in a surface mount package. And what makes this part especially appealing is the fact that it is a gallium arsenide part, so it requires a drain bias of 6 volts, and therefore it can be fairly easily powered off the common 12 volt supply. This particular part has a saturated output power of 34.5 dBm, which is a little bit more than 2 watts, and has a fairly high gain of 24 dB. And if we look down here a little bit further in the technical data, we see basically that this part has a fairly nice little gain hump in between 11 and 11.5 gigahertz, but it has fairly decent output power down at 10 to 10.5 gigahertz already. And you can see down here in this particular curve right here that you get this with about 10 dBm drive power, you get 34 dBm output power. So it's a fairly nice little part, and you can also run it with different bias points. The standard bias is basically 6 volts and 1.3 amps, but you can also run it at 6.5 volts and 1 amp, and as we see down here, basically the power 10.5 gigahertz increases to 35 dBm. So I created a circuit board for this particular part, and then basically assembled it in a nice little machined aluminum housing. And so essentially, if you look at it, there's not really this much in here. It's basically the part itself and a couple of bypass caps. What's notable about it is basically the drain bias is fed from the top and from the bottom terminals, so those are jumpered together on the outside. For the RF connectors, I'm using SMA connectors, and those are field replaceable. So you basically use those little contact pins right here that are going through the wall of the housing, and that basically makes it fairly easy to replace the connectors if somebody ever wants to put something. If you break a connector or you want to put a 3.5 millimeter 2.92 on it, then it's fairly easy to do. You don't have to desolder anything. And so the whole circuit board is screwed in with 256 screws, one on each side, and then there are 2 little odd 80 screws right here close to the port itself, and so it's basically ensures that the circuit board is pressed down good to optimize the heat transfer from the port to the housing, because the housing basically also acts as heat sink. And with QFN packages, it's always, from the thermal standpoint, a little bit challenging to work with them. It's also takes a little bit of practice to place them and solder them. So I'm using usually a little cheap reflow oven I got off Amazon, and it works fine for this kind of stuff. Then also there you see those 2 little resistors up here. Those are essentially bias resistors for a built-in power detector. This power detector right now is not used, it's not hooked up, so but it can be utilized for future reference. So the first thing I want to do is I want to take measures the small signal gain and frequency response on my network analyzer. I already got power supplies hooked up. I got the network analyzer calibrated from 5 to 12 gigahertz. I'm using a input power of minus 30 dBm, so that gives me enough room to make sure that my network analyzer does not get damaged in any form or fashion. And up here I have my power supply. Power supply is set to 6 volts. You see, current limit is set to 1.49 amps or 1.5 amps. It's always a good idea when working with power amplifiers and you don't use a specific bias board yet to kind of set a low current limit first. Make sure that you have gate control. So the gate right now I set to 1 volts, and as we can see there's a very small drain current flowing. So now we want to set this to 1.3 amps. So okay, so I'm at 1.3, and now let's look at the frequency response. So we see down here that my marker, my first marker, is at 10 gigahertz, which is the beginning of the ham band. So you got 32, 23.25 dB gain. And remember the data sheet said about 24, so I'm nicely where I need to be. Up at the high end where the port tapers off, it's 12 gigahertz essentially. At 12 gigahertz I'm still getting 21.7 dB gain. So it's overall looks really nicely, and as you can see here I got this housing basically in a drill press vise, so it kind of acts as a monster heatsink, and this one is not even getting warm. So later on we're gonna put the lid on it, and as you can see there are like 2 little holes here and here, and those holes essentially serving the purpose of bolting support down on a heatsink. And so now the next thing I want to do is I want to measure the output power, and this is subject of the next video. Thank you for watching. Please like my video and share it, and if you have any needs for power amplifiers, microwave amplifiers, feel free to reach out to me. I'm actually also selling those modules and other modules, including this particular 4-watt amplifier right here, and then we also have a 8-watt power amplifier right here, and I'm also building higher power ones up to about 32 watts right now. Thank you and for stopping by, and I see you later.